So good morning guys. Today I will bring you a question on axial loading which was asked in GATE. So let's look up on the question. Okay. So it is given that a bar having a cross sectional area 700 mm square. So area given is 700 mm square and it is a bar of uniform cross section area. Uniform cross sectional area we can see. Okay. Uh, this we have seen the value of stress at various segments we have means the load is given as various points and we need to find the stress of the segment QER. Okay, this we need to find stress of the value. Okay, so how to approach the question? The approach should be on the basis of free body diagram, FBD. FBD approach should be used and then we will use the formulas of stress and whatever it is required. Okay, so first of all let's look at the if we move from left hand side from left hand side, so we will make the FBD of each and every section. Okay, so PQ section. Okay, this we can see, this is PQ. Here we can see a load of 63 kilonewton is applied. So in this we will see, we will see, we will look on the section up till point Q, but just before point Q. Okay, so this is PQ. So here we have 63 kilonewton. So by balancing, this should be also 63 kilonewton. Okay. So moving on to next section, we have QR section. Okay. So what to write here? So here 63 kilonewton is acquired just before Q, and this is acting in this side. So here it will act in opposite direction. This is 63 kilonewton, but here we can see 35 kilonewton force is applied here. Okay, so net force in left hand direction, what will it will come is 63 minus 35, which is equal to 28 kilonewton. Okay, and so balancing right towards the right, it will also be at 28 kilonewton. Okay, moving on to the last section. See, last section is our RS section. Here we can see 28 kilonewton is applying towards R. So opposite of 28 kilonewton will act towards the left hand side. Okay, to 28 kilonewton, and this we can see again 49 kilonewton force is acting on this side. So what will be the net force? 28 minus 49, which is 21 kilonewton. But what will be its direction? This will be, it is coming minus 21 kilonewton, minus 21 kilonewton towards left. So ultimately, this we can draw as 21 kilonewton towards RHS. So again, it will come 21 by balancing. This will 21 kilonewton, and this we can verify. See, we were looking up till just point S, but we see it is balancing this force. So we can see our FBD is balanced FBD. It will never violate our equilibrium, which is uh, force acting in a particular direction if in x direction should always balance. Okay, equilibrium condition. So what is our point to be noted? QR section. We need to find the stress of the segment QR. So what is the force acting on the segment QR? This is 28 kilonewton. The force on QR section, it is 28 kilonewton. What we need to find? Stress. Stress for the section QR. We can write stress is equal to force upon area. As simple as that. Okay, this is 28 kilonewton by area of the cross section bar is given as 700 mm square. So we will use SI units, convert them into SI units. Okay, the stress is equal to 28 into 1000 divided by is 700 into 10 to the power minus 6. This will come for Newton per meter square. Okay, so solving it, we will get 40 into 10 to the power minus 6 Newton per meter square. So what is our units of concern? Answer is given as MPa. MPa it is given. It is 40 into 10 to the power plus C. It is minus 6 here power, so it will become plus 6 when it goes upwards. Okay, two zeros will cancel. 280 by 7, it is 40. Okay, so 40 into 10 to the power 6, we can write 40 mega Newton per meter square, which is our MPa. Okay, this is unit is our MPa. So it is our 40 MPa. Hence our answer. Okay. So main learning, what was our main learning? To divide each and every section and look on the forces acting and on which direction it is acting. And for a single time, for a single section, we will consider only the section. For if we're moving towards left, from left towards right, we will consider the section just before the point of contact on the right hand side, and then we will add balancing. For the next section, we will include the forces in that section up till point R, but just before the point R. Okay, but 49 we can see it is acting at R, and that's why we haven't included the 49 kilonewton force in this FBD. Okay, and this we were acting in the last section. Okay, guys, thank you. This was a great learning for us, and it will help you solve questions and get